you would go ahead in your notes and get them ready, write chapter 1.6 distance formula, and then make sure you get both essential questions written down. During the video, if I'm going too fast, feel free to pause it and catch up on the notes. And at the end of the video, when you're done, you will show the sub your notes, and then she will give you the homework. It's not going to be on the video. All right, the first thing we're going to do is learn how to derive the distance formula. Derive just means where did the distance formula come from. So go ahead and draw this graph in your notes. And what we're going to do is label these points x1, x2, y1, and y2. All that does is mean an x and a y point in general. So what I'd like you to do is put a point here at x1, y1, and then put a point at x2, y2. What we're going to do is see if we can find the distance between those 2 points. So let's go ahead and call that distance C. Maybe using a different colored marker or dash line, what can happen is we can make a right triangle that connects those 2 points. We're going to see if we can use the Pythagorean theorem to actually find what this distance formula is. And once we have the formula, we will be able to find the distance between 2 points. So again, let's go ahead and label this point x1, y1, and this point x2, y2. If we wanted to find the distance, see how long this red dash line would be, we would subtract the y2 from the y1. That would give us the distance of that red dash line. If we wanted to find the distance between this line, we would take x2 and subtract x1 from that. So let's go ahead and see if we can use the Pythagorean theorem to solve for C. Remember, our Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of the triangle. So I know the bottom leg of that triangle is x2 minus x1. I'll square that. The other leg of the triangle is y2 minus y1, and I'm going to square that. That's all equal to the hypotenuse, which we know is C because it's across from the right angle. Now, if we wanted to actually figure out what C was, to undo that square, we would take the square root of both sides. So what we get is that C, the length of C, is this big square root. Underneath, we get x2 minus x1 squared plus y2 minus y1 squared equals C. That gives you the distance of the length C. So what we've done is we've just found the distance formula. So what I'd like you to do is on the left side of your Cornell notes, write distance formula. That tells you the distance between 2 points. And again, we call those points in general x1, y1, and x2, y2. So let's go ahead and get that distance formula written in our notes one more time. We have y2 minus y1 squared plus x2 minus x1 squared and a big square root. Notice on the last page we had it flipped around. We got x2 minus x1 squared first. It does not matter. You're adding the two together, so the order doesn't matter. Either way you write it is correct. All right, I would like you to write down example 1. If you just want to draw the first quadrant, you can. What we're trying to do is find the distance between J and K. If you're going to do that, you need to know 2 points. So after you get this drawn, I want you to see if you can figure out the point that would represent J and the point that would represent K. If you look at K, that's the point 3, 0. And the point J is 3, 5, over 3, up 5. So what I'm going to do is use those 2 points to help me find the distance between J and K. So I've got the point 3, 5 and the point 3, 0. What I like to do when I'm using the distance formula is actually label my 2 points. So I can call this one x1, y1, and this one x2, y2. It doesn't matter which point you call x1, y1, and which one you call x2, y2. You will get the same answer either way. So what we're going to do is plug it into our distance formula. I'm going to write it out one more time so you can see where we're actually substituting in. Alright, y2 is the value of 0, minus y1 is 5 squared, plus x2 is 3, minus x1 is 3 squared. What we're actually going to do here is go through and simplify these values. So under the first parentheses, 0 minus 5 is negative 5. And we'll square that. 3 minus 3 is 0, so that goes away. You can write it in this step for now so you can see that it is just 0. I'm going to keep simplifying under the radical. So negative 5 squared is 25. 0 squared is 0, so I'm not going to write that anymore. The square root of 25 is 5. If you did not remember that the square root of 25 is 5, you could use your calculator, or you could make a factor tree. So if we scroll back up and look, the distance between J and K is 5. On this coordinate plane, you can actually count the squares and see that the distance is 5. You will not always be able to do that, though, which is why we need to know the distance formula. All right, on to example 2. So again, you need to copy this coordinate plane in your notes. If you need to pause the video, you can. You have to find the order pairs that represent H and I. And by doing that, you're just counting on the X and the Y axis. So I is the point 5, 3. Over 5, up 3. H is the point negative 4, 9. You go left 4 units, up 9 units. Again, we're going to use those 2 points to find the distance between H and I. I always like to start by labeling the points x1, y1, x2, y2. Again, it does not matter which one you label x1, y1 and which one you label x2, y2. If you think it's helpful, you can rewrite the distance formula every time to remember all you're doing is replacing those values. So I have labeled y2 as the number 3 minus y1 is 9, and we square that. x2 is 5 minus a negative 4, so I'm going to rewrite it like this and square it, and we'll talk about how we simplify that in a minute. So if you look at your first set of parentheses, 3 minus 9 is negative 6, and we're going to square that, plus 5 minus a negative 4 as this is the same thing as 5 plus 4. So we get 9 squared. Underneath the radical, we're going to simplify negative 6 squared. Negative times a negative is a positive. So we end up with a positive 36 plus 81, because that's what 9 squared is. Underneath the radical, when you add them together, we should get the square root of 117. Now that is not a perfect square. If you plugged that in your calculator, you would get a decimal. So again, what we need to do is make a factor tree. We can split 117 into 3 times 39. If you use different factors, that's okay. And we can split 39 into 3 and 13. So we've got a group of 3's and a 13 left over. So your final answer is the distance is 3 radical 13. That's the difference, the distance, between H and I. So that one we would not be able to actually count on the coordinate plane, which is why we need to know this distance formula. All right, we've got a few more that we're going to try by just giving points. This time you're not actually given a coordinate plane, so you don't have to count what the ordered pairs are. You're just given the ordered pairs. So we're given that Q is 12, negative 12, and T is 5, 12. So again, I'm going to label them. If you feel like you don't need to label them, that's okay. Just be very careful when you plug them into your distance formula. I always start by rewriting the distance formula, so I make sure I plug the numbers in the right place. So y2 is 12 minus y1, so minus a negative 12. Be very careful with those negatives. X2 is 5 minus x1 is 12. And take the square root of the whole thing. Do not forget to write the square root every single step. So if you look at the first parentheses, 12 minus a negative 12 is 12 plus 12. So we should get 24 underneath the radical. Plus 5 minus 12, we should get a negative 7. I always put my negative numbers in parentheses. And we're still taking the square root of the whole thing. Use your calculators if you need to. 24 squared is 576. A negative 7 squared is a positive 49. Whenever you square a negative number, you get a positive number. Add those together and you get 625. 625 is a perfect square. The square root of it is 25. So this time you do not need to make a factor tree. Only if the square root gives you a decimal. All right, we're going to move on to example 4. You're given that R is the 0.05, S is the 0.123. I'm going to switch it up this time and maybe write this one as x2, y2, and this one is x1, y1. Just to re-emphasize that it does not matter which one you label. All right, if I go ahead and plug it into my distance formula, y2 is 5 minus y1 is 3 squared plus x2 is 0 minus x1 is 12 squared. Simplify what's underneath the radical. 5 minus 3 is 2, so you're left with 2 squared. Plus 0 minus 12 is a negative 12. Again, write that negative in parentheses so you don't forget it. 2 squared is 4. 12 squared is 144. If you add them together, we have the square root of 148. If you do that in your calculator, you will get a decimal. So, just like before, we need to make a factor tree. We can split that into 4 and 37. 4 goes into 2 and 2. 37 is a prime number. So when you simplify, you will get 2 square roots of 37. All right, these last 2 examples can be your you try. So if you want to pause the video and try to do it on your own and then press play, you can check your answers that way. Again, I'm going to label the points x1, y1, and x2, y2, and write down my distance formula. that we've labeled the points, it makes it easy for us to plug in our distance formula. Y2 is 4 minus Y1. So we've got minus and negative. So again, put that in parentheses. If we look at our x values, x2 is negative 2 minus x1 is 6 squared. And then we've got the square root over the whole thing. 4 minus a negative 2 is a positive 6. So underneath we have 6 squared. Negative 2 minus 6 is a negative 8. So we're going to be squaring a negative number. Underneath the radical, 6 squared is 36. Negative 8 squared is a positive 64. So under the radical we should have a square root of 100. Which we know is a perfect square, so my final answer is 10. The distance between E and F should be 10 units. All right, your last U try, you can go ahead and pause the video again and try this one on your own. E is the point 20, F is the point 810. Last time, I'm going to label them x1, y1, x2, y2, and write my distance formula. Now that you've labeled the points, you can plug them in the formula. Y2 is 10 minus y1 is 0 squared plus x2 is 8 minus x1 is 2 squared, all under the square root. 10 minus 0 gives you 10, so we're going to square that. 8 minus 2 gives you 6. 6 squared, and then underneath the radical. So we should have 100 plus 36. So underneath the radical, we'll have distance equals the square root of the 136. If you go to simplify that in your calculator, you will get a decimal, so you need to make a factor tree with the square root of 136. That can split into 2 and 68. 68 we can split into 4 and 17. 17's prime, so I'm going to split 4 into 2 and 2. I've got a group of 2's and a 2 and a 17 that are left over. So the distance, I'll have a 2 outside of the square root, and underneath I'll have 2 times 17, so I'll have 34. And that would be the distance between E and F. When you're finished writing this problem down, you can go show the sub your notes, and then she will give you your homework.